If the universe were polite, space travel would be simple. But the universe, I am afraid, has never been interested in being polite. People often imagine space as emptiness, a quiet nothingness where you simply point a rocket, press a button, and go. But space is not empty. It is structured. It is curved. And above all, it is ruled by gravity with an authority that does not negotiate. When you wish to travel to another planet, physics immediately presents you with an uncomfortable truth. The straight line is almost always impossible. And the reason for this is not technology. It is not a lack of intelligence. It is not even a lack of ambition. It is nature reminding us who is in charge. The first illusion. Just aim and go. Let us begin with the most common mistake. Someone looks at Mars in the night sky and says, "Why don't we just point a spacecraft there and fly straight?" Because Mars will not be there. Planets do not sit patiently waiting for visitors. They move quickly. By the time a spacecraft arrives months later, Mars has traveled hundreds of millions of kilometers along its orbit. Space travel is not archery. It is chess played on a moving board. You must aim not at where the planet is, but where it will be. And that already requires humility before mathematics. But this is only the beginning of our troubles. The tyranny of fuel. Now we come to the true dictator of spaceflight, fuel mass. A rocket is a paradoxical machine. The more fuel you add, the heavier it becomes. The heavier it becomes, the more fuel it needs to carry the fuel. This vicious loop is described by an equation so unforgiving that engineers whisper its name with respect. The rocket equation. It says, quite plainly, if you want more speed, you must pay exponentially more fuel. And rockets do not burn forever. They burn for minutes. Then they are silent. After that moment, the spacecraft becomes a passenger of gravity. No brakes, no steering wheel, only physics. Leaving Earth is the easy part. Escaping Earth's gravity is dramatic, yes. Fire, noise, thunder. But it is also brief. A massive rocket like Ariane 5 burns for about half an hour. That is all. After that, it has already spent nearly all its fuel, yet it has not even traveled 1% of the distance to Mars. From this moment onward, the spacecraft must survive on momentum and planning. And now we face a second nightmare: arriving. The arrival problem nobody thinks about. Getting somewhere is not enough. You must also stop. If a spacecraft arrives at a planet too fast, it will fly past forever. A cosmic insult, waving goodbye as it disappears into deep space. Slowing down requires fuel. Fuel requires mass. Mass requires more fuel. Once again, physics tightens its grip. So the question becomes unavoidable. Can we travel far without carrying the fuel to do it? And here, finally, physics smiles. The great insight: stealing without theft. In the early 20th century, a few stubborn thinkers realized something extraordinary. Planets are moving very fast. What if we could borrow a little of that motion? Not by engines, not by force, but by geometry. When a spacecraft approaches a planet, it falls into its gravity well. The planet bends its path like a stone swung on a string. Relative to the planet, the spacecraft enters fast and leaves fast. No energy gained. But relative to the sun, that is where the magic happens. The gravitational slingshot. Imagine throwing a tennis ball at a moving train. From the train's perspective, the ball comes in and goes out at the same speed. But from your perspective, the ground, the ball leaves with extra speed. It has stolen motion from the train. This is not cheating. This is conservation of momentum doing something beautiful. A spacecraft can do the same with a planet. It swings around Jupiter and leaves faster. It loops past Venus and slows down. No engines fired, no fuel spent, only patience, mathematics, and exquisite timing. The quiet heroes of celestial mechanics. This idea was not born overnight. Friedrich Sonder imagined it in theory. Michael Minovich proved it mathematically. Giuseppe Bepi Colombo dared to use it. Without them, the solar system would still be locked behind an impossible fuel bill. Because of them, we learned to surf gravity instead of fighting it. Why spacecraft paths look insane. Now you understand why spacecraft paths look absurd. They loop inward toward the sun before going outward. They pass Earth again after leaving it. They visit planets they were never meant to study. This is not confusion. This is strategy. The spacecraft is not traveling through empty space. It is navigating a river of gravity. Just as a sailor cannot sail straight across an ocean without respecting currents, a spacecraft cannot travel straight across the solar system. The shortest path is rarely the fastest. The fastest path is rarely affordable. Speed, mass, time. Pick two. Here is the brutal law of interplanetary travel. You may choose two of the following: speed, low mass, short time. Never all three. If you want speed and short time, you must pay enormous mass. If you want low mass and speed, you must wait many years. If you want low mass and short time, physics laughs. Gravity assists are the compromise we accept. They save mass, they save fuel, but they demand time. Why missions take decades? Planets do not align on human schedules. Sometimes the correct gravity dance occurs once every decade. Miss it, and you wait. This is why missions are planned 20 or 30 years in advance. This is why politics and spaceflight struggle to coexist. Physics does not care about election cycles. Slowing down is as hard as speeding up. Even when you arrive, gravity is not done with you. To be captured, you must lose energy. Sometimes we burn engines. Sometimes we skim atmospheres. Sometimes we perform multiple flybys, slowly bleeding speed like a cosmic brake pad. Once again, no shortcuts. The deep truth. Interplanetary travel is not about power. It is about understanding. It is not brute force. It is cooperation with the universe. You do not conquer space. You negotiate with it. The final lesson. So when you see a spacecraft looping absurdly through the solar system, remember, that curve is wisdom. That delay is efficiency. That detour is survival. The universe does not reward impatience. And that is why physics quite literally drives you around the bend when you wish to travel to other planets. Because the universe does not care where you want to go, only how well you respect its rules.